Well, let us equip you to be able to critically appraise research projects and research papers. So we are now starting critical appraisal. So, what are the common errors that can occur in research? The first one is confounding. For example, if I say that conservative treatment of intercondylar fractures versus operative treatment and good results and bad results, supposing 80 out of 100 had good results in the conservative group and 40 out of 100 had good results in the operative group. Here the number will be 20 and here the number will be 60. Therefore, the risk of good results in the conservative group is 80 upon 100 and the odds is 80 upon 20. In odds, the denominator does not contain the numerator. So here it is 40 upon 100 and here it is 40 upon 60. If you divide this by this, you get the odds ratio and you see the risk ratio here is about 2. So you have 2 times better chances of having good results in intercondylar fractures with conservative treatment as compared to operative treatment. Now my resident says that, sir, less displaced fractures were more in the conservative group and more displaced fractures were more in the operative group. And it is not the conservative and operative, but the more displaced and the less displaced fractures that explain this difference. Now, this factor, the displacement, is called as the other explanation of the results that we are seeing. And this is a confounder. So, how to control for confounding? Supposing there were a group of intercondylar fractures, we treated them operatively and conservatively. We followed them forward in time and tried to find out how many had good results in this group. Good results here, bad results here. So we make the 2 by 2 table in the 2 groups. Supposing we draw this table, so first thing that we could do is that for each undisplaced in the operative group, we take the same undisplaced in the conservative group. So displaced, undisplaced versus displaced and undisplaced versus displaced become equal in both groups. Since they are equal in both groups, displacement will not be able to affect the results here. So this technique is called as matching. Then there can be that we'll only take the undisplaced fractures. Again, both groups become matched on the type of displacement, and this is called as restriction. So restriction, matching. The third thing that can happen is that we can draw these 2 by 2 tables separately for displaced and undisplaced fractures. So these numbers are only for displaced fractures and these numbers are only for undisplaced fractures. Therefore, we will get 2 risk ratios, RR1 and RR2. And if they are similar, we are able to combine them, and this is called as adjusted RR for confounder and displacement. of a confounder displacement. This is called as stratified analysis. Finally, we can randomly allocate to the conservative and operative group, and this random allocation done over a sufficient sample size would render the conservative and operative groups equal on all known and unknown confounders and this part of equalizing on unknown confounders, the most powerful component of random allocation. Therefore, random allocation is the best strategy to control confounding because it deals with unknown confounders.
Yes.
So I think with this we finish confounding. The final thing is, if there are multiple confounders, supposing you are not you are only observing like smoked, unsmoked, blood pressure high
Diabetes.
or low, diabetes present or absent. So you are only
Lifestyle,
observing. You are not administering the exposure. It's not an experimental study, it's an observational study. Then the method of controlling confounding can be regression analysis. And here is the event of interest. That means cured, not cured, good result, bad result, is equal to some number which is beta 0 plus beta 1 x1 plus minus beta 2 x2 plus minus dash 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 beta n xn. So supposing this is the treatment variable, x1 is the treatment variable, conservative or operative. Here the beta ratio is giving you the relationship of x1 to the event of interest, keeping all other factors constant, x2 to xn constant. So this is the method of being able to deal with multiple confounding in observational studies. In the next class, we will approach confounding is God-made. In the next class, we will approach the errors which are man-made in study designs, which you have to look for. Thank you.